Hello there, and welcome to Midnight Science. I'm so glad you're here. Maybe the day has been long, or maybe you simply love drifting off while thinking about stars, galaxies, and the vast, mysterious cosmos that surrounds us. Either way, tonight is for you. There's nothing you need to do now. Just let your body settle, your mind soften, and your thoughts begin to float. Because tonight, we're journeying outward, beyond Earth, beyond the solar system, into the deep and quiet reaches of space itself. We'll drift through black holes and nebulas, past dying stars and newborn galaxies, listening to the whispers of cosmic events that happened billions of years ago. Some facts may surprise you. Others may simply wash over you like starlight on water, gentle and soothing. And if these calm explorations help you rest, feel free to like and subscribe. It helps others find their way here too. Now, if you're ready, let's begin. The universe is mostly empty space. When we picture the cosmos, we often imagine it crowded with stars, planets, and glowing clouds of gas. But in truth, the universe is overwhelmingly empty. The distances between objects are so vast that if you were to travel from one star to the next, you'd spend years, even centuries, crossing nothing but void. Even within galaxies, where stars seem packed together, the space between them is immense. Our own solar system is mostly emptiness. If the sun were the size of a basketball, the nearest star would be thousands of miles away. This emptiness isn't lifeless though. It hums with faint radiation, invisible fields, and the soft echo of ancient light. The universe is a cathedral of silence, vast and still, with points of brilliance scattered like candles in an infinite dark. Light from distant stars is older than human civilization. When you look up at the night sky, you're not seeing the universe as it is now. You're seeing it as it was. Light takes time to travel, and the farther away something is, the older the light reaching your eyes. Some stars you see tonight sent out their light hundreds or even thousands of years ago. That means the photons entering your eyes began their journey before written language, before cities, before agriculture. You're looking into the past with every glance upward, and for the most distant galaxies, observed through telescopes, the light has been traveling for billions of years. By the time it reaches us, those galaxies may have changed entirely or ceased to exist. The night sky is a gallery of ghosts, each one a moment frozen in time, still glowing softly across the ages. Black holes aren't black, they're invisible. We call them black holes, but that's not quite right. They don't emit light, so they can't be seen directly. What we observe instead is the absence of light, a void where something massive bends space so intensely that nothing, not even light, can escape. Around this void, matter spirals inward, heating up and glowing brilliantly before it vanishes forever. That glowing disk is what we see. The black hole itself remains hidden, a silhouette against the universe. In 2019, scientists captured the first image of a black hole's shadow, a dark circle surrounded by a halo of light. It was like photographing the invisible, revealing a shape that exists only as negation. Black holes don't announce themselves. They simply erase, quietly and completely, leaving only the faintest trace in the fabric of space. Neutron stars are the densest objects in the universe. Imagine crushing an entire mountain into the size of a sugar cube. That's the kind of density found in a neutron star. These are the remnants of massive stars that exploded in supernovas, leaving behind a core so dense that a single teaspoon of its material would weigh as much as 1 billion tons. Neutron stars are only about 20 kilometers across, roughly the size of a city, yet they contain more mass than the Sun. Inside, the pressure is so extreme that protons and electrons merge into neutrons, forming a kind of nuclear fluid. Some neutron stars spin hundreds of times per second, emitting beams of radiation like cosmic lighthouses. These are called pulsars, and their timing is so precise they rival atomic clocks. Small, silent, and impossibly heavy, neutron stars are nature's most extreme compression, remnants of violence now frozen in stillness. The universe is expanding faster than we thought. For decades, scientists believed the universe was expanding at a steady, predictable rate. But in the late 1990s, observations of distant supernovas revealed something unexpected. The expansion is accelerating. Galaxies aren't just drifting apart, they're being pushed apart faster and faster. The cause is something we call dark energy, though we don't really know what it is. It seems to be a property of space itself, a force that grows stronger as the universe grows larger. This discovery was so surprising it earned a Nobel Prize. It means that in the far future, galaxies beyond our local group will recede so quickly that their light will never reach us. The universe won't collapse or freeze. It will simply stretch, gently and relentlessly, into an ever-deepening silence. Stars are born in clouds of gas and dust. Stars don't appear from nowhere. They form in vast clouds called nebulas, regions of space filled with hydrogen, helium, and traces of heavier elements. These clouds can span hundreds of light years, drifting slowly through the galaxy. When a region of the cloud becomes dense enough, gravity takes over, pulling material inward. The center heats up as it compresses, and eventually, nuclear fusion ignites. A star is born. The process can take millions of years, and not all clouds give birth to stars. Some remain cold and dark, waiting for a trigger, a shock wave from a nearby supernova perhaps, or the passage of a spiral arm. But when conditions align, the darkness glows. What was once invisible becomes radiant, and a new light joins the chorus of the cosmos. There are more stars than grains of sand on Earth. It's hard to grasp the scale of the universe, but here's one way to think about it. If you gathered every grain of sand from every beach, desert, and ocean floor on Earth, you'd have roughly 7.5 quintillion grains. That's a lot, but the number of stars in the observable universe is even greater, estimated at around 100 billion trillion. That's more stars than grains of sand. Each one is a sun burning in the dark, and many of them have planets. Some of those planets may harbor life. When you hold a handful of sand, remember that the cosmos holds more suns than that, scattered across distances so vast we can barely name them. The universe isn't just big, it's unfathomably abundant. Time moves slower near massive objects. Einstein's theory of general relativity tells us that time is not absolute. It flows differently depending on where you are and how fast you're moving. Near a massive object like a planet, star, or black hole, space-time curves, and time slows down relative to regions farther away. This isn't just theory, it's been measured. Atomic clocks on airplanes tick slightly faster than those on the ground. GPS satellites have to account for this effect, or they'd give inaccurate positions. Near a black hole, the effect becomes extreme. if you could hover just outside the event horizon and then return, you'd find that far less time had passed for you than for someone far from the black hole. Time, it turns out, is flexible, shaped by gravity, bent by mass, and always relative. Most galaxies have a supermassive black hole at their center. At the heart of nearly every large galaxy, including our own Milky Way, lies a supermassive black hole. These aren't the stellar black holes formed from dying stars. They're millions or even billions of times more massive than the Sun. We don't fully understand how they formed, but they seem to play a crucial role in shaping galaxies. The black hole at the center of the Milky Way is called Sagittarius I, and it has a mass of about 4 million suns. Despite this, it's relatively quiet, only occasionally consuming gas or dust. Other galaxies have far more active black holes, which pull in matter at tremendous rates, heating it until it glows brighter than the entire galaxy. These are called active galactic nuclei, and they can be seen across the universe. At the center of light lies darkness, vast, silent, and strangely essential. Galaxies collide, but stars rarely do. When two galaxies merge, it sounds like a cosmic catastrophe, and in some ways, it is. Gas clouds slam together, triggering bursts of star formation. Dust lanes twist into new shapes. Supermassive black holes spiral toward each other, eventually merging in a burst of gravitational waves. But for all this chaos, the stars themselves almost never collide. That's because the distances between them are so enormous. Even in the densest regions of a galaxy, stars are separated by light years. When galaxies collide, it's more like two clouds passing through each other. The stars drift past one another, their paths only slightly altered by gravity. The result, over millions of years, is a new galaxy, reshaped and reformed, but built from the same stars. In the grand dance of the cosmos, collisions are gentle, not violent. The coldest place in the universe is on Earth. You might expect the coldest spot in the cosmos to be in deep space, far from any star. And it's true that intergalactic voids can drop to just a few degrees above absolute zero. But the coldest place we know of is actually here on Earth, in a laboratory. Scientists have used lasers and magnetic fields to cool atoms to within a billionth of a degree above absolute zero, colder than anything naturally occurring in the universe. At these temperatures, matter behaves strangely. Atoms slow to a near halt, forming exotic states like Bose-Einstein condensates, where particles blur together into a single quantum entity. It's a glimpse into the deepest stillness matter can achieve, a kind of silence colder than the void itself. Pulsars are cosmic clocks. When a massive star collapses into a neutron star, it often begins to spin rapidly, sometimes hundreds of times per second. If the neutron star has a strong magnetic field, it emits beams of radiation from its poles. As it spins, these beams sweep across space like a lighthouse, and if one points toward Earth, we see a pulse of light. These are pulsars, and they're some of the most precise timekeepers in the universe. Their pulses are so regular that scientists use them to test theories of gravity, search for gravitational waves, and even navigate spacecraft. A pulsar's rhythm is written into the structure of the star itself, carved by physics into a cosmic metronome, ticking silently across the galaxy. The sun loses mass every second. The sun may seem eternal, a constant source of light and warmth, but it's slowly losing mass. Every second, it converts about 4 million tons of matter into energy through nuclear fusion. This energy radiates outward as light, heat, and particles streaming into space. Over the Sun's lifetime, it has lost roughly the mass of the planet Saturn. That might sound like a lot, but compared to the Sun's total mass, it's a tiny fraction. Still, this gradual loss is a reminder that even stars are finite. They burn, they shine, and slowly, almost imperceptibly, they fade. The light warming your skin today was bought at the cost of the Sun's own substance. A quiet sacrifice repeated every moment. Some exoplanets are made of water. When we think of planets, we usually imagine rock or gas. But some worlds discovered beyond our solar system are almost entirely water. These are called ocean worlds or water worlds, and they're larger than Earth but less dense. Beneath thick atmospheres of steam, they may have global oceans hundreds of kilometers deep. At the bottom, the pressure would be so intense that water might freeze into exotic forms of ice, even though the temperature is high. These worlds are strange and alien, places where the ocean has no floor, only deeper and denser layers pressing down into the dark. Life as we know it would struggle there, but perhaps something else could thrive, drifting in the endless deep. The Big Bang wasn't an explosion in space. It's tempting to imagine the Big Bang as a massive explosion, matter bursting outward into empty space. But that's not quite right. The Big Bang was the beginning of space itself. There was no outside for it to expand into. Instead, space, time, matter, and energy all emerged together in that first moment. As the universe expanded, it wasn't matter moving through space, it was space itself stretching, carrying matter along with it. This expansion continues today, and it means that the universe doesn't have a center. Every point in space can be thought of as the center, because everything is moving away from everything else. The Big Bang wasn't an event in space, it was the birth of space, quiet, strange, and still unfolding. Stars die in different ways depending on their mass. Not all stars in the same way. Small stars, like red dwarfs, burn slowly and can last for trillions of years. When they finally run out of fuel, they simply fade, cooling into dark remnants called black dwarfs. Medium-sized stars, like our Sun, swell into red giants, shed their outer layers, and leave behind white dwarfs, hot cores that slowly radiate away their heat. But massive stars die dramatically. When they exhaust their fuel, their cores collapse in a fraction of a second, triggering a supernova, an explosion so bright it can outshine an entire galaxy. What remains depends on the star's mass. If it's massive enough, the core becomes a neutron star. If it's even heavier, it collapses into a black hole. Death in the cosmos comes in many forms, some quiet, some spectacular. The universe might be shaped like a donut. We don't know the exact shape of the universe. It could be flat, curved, or even have a more complex topology. One possibility is that the universe is shaped like a three-dimensional torus, essentially a donut. If that's true, you could travel in a straight line and eventually return to where you started, not because you hit an edge, but because space loops back on itself. This is called a closed topology, and is similar to how a video game screen wraps around at the edges. We haven't found evidence for this yet, but it's not ruled out. The universe might be stranger than we imagine, folded in ways that defy our intuition. A cosmic shape we're still learning to trace. Some stars orbit each other so closely they touch. Most stars live alone or in pairs at comfortable distances. But some binary stars orbit so closely that their outer layers actually touch, forming what's called a contact binary. Gas flows between them, pulled by gravity and centrifugal force, creating a shared envelope. From a distance, they might look like a single peanut-shaped object glowing and spinning. These systems can be unstable. Sometimes the smaller star is gradually consumed by the larger one. Other times, they spiral inward and merge, potentially triggering an explosion. It's a cosmic embrace, intimate and dangerous. Two stars locked together in a dance that may end in union or destruction. Dark energy makes up most of the universe. When we add up everything we can see, stars, planets, gas, dust, it accounts for less than 5% of the universe's total content. Another 27% is dark matter, invisible but detectable through its gravitational effects. The remaining 68% is dark energy, a mysterious force that drives the accelerating expansion of the universe. We don't know what dark energy is. It doesn't clump like matter. It doesn't interact with light. It simply fills space, exerting a gentle but relentless push. The more the universe expands, the more dark energy there is, and the faster the expansion becomes. It's the dominant force in the cosmos, and yet it remains one of the deepest mysteries in all of science. The Milky Way will collide with Andromeda. Our galaxy, the Milky Way, is on a collision course with the Andromeda Galaxy, our nearest large neighbor. Right now, Andromeda is about 2.5 million light-years away, but it's moving toward us at roughly 110 kilometers per second. In about 4 to 5 billion years, the two galaxies will begin to merge. The collision will be slow and graceful, unfolding over hundreds of millions of years. Stars will pass by each other, and new bursts of star formation will light up the combined galaxy. Eventually, the Milky Way and Andromeda will become a single elliptical galaxy, sometimes nicknamed Milkomeda. It's a distant future, but it's coming, written into the motion of galaxies across the sky. Gamma-ray bursts are the universe's brightest events. For a few seconds, a gamma-ray burst can release more energy than the sun will emit in its entire 10 billion year lifetime. These are the brightest electromagnetic events known, and they're thought to occur when massive stars collapse into black holes or when neutron stars collide. The burst is focused into narrow beams, like cosmic searchlights. If one were pointed at Earth from within our galaxy, it could strip away the ozone layer and cause mass extinctions. Fortunately, they're rare and distant. Most occur in faraway galaxies, billions of light years away. We see their afterglow, fading over days or weeks, a brief flash of unimaginable violence echoing across the cosmos. There's a giant cloud of alcohol in space in the constellation. Aquila, about 10,000 light-years from Earth, there's a cloud of gas and dust containing enough ethyl alcohol to fill 400 trillion pints of beer. This cloud, called G34.3, is a star-forming region, and the alcohol is mixed with other organic molecules. It's not drinkable, of course. It's diffuse, cold, and laced with toxins. But it's a reminder that space is full of chemistry. The building blocks of life, carbon, oxygen, nitrogen, are forged in stars and scattered through space, where they combine into complex molecules. Amino acids, sugars, and alcohols drift through the void, quiet ingredients waiting for the right conditions to spark something new. The sun's light takes thousands of years to escape its core. When a photon of light is created in the sun's core through nuclear fusion, it doesn't immediately shoot out into space. Instead, it begins a long, chaotic journey. The core is so dense that photons are constantly absorbed and re-emitted by atoms, bouncing randomly in every direction. This random walk can take anywhere from 10,000 to 170,000 years before the photon finally reaches the sun's surface. Once it breaks free, it travels through space at the speed of light, reaching Earth in just 8 minutes. The light you see today was born tens of thousands of years ago, deep in the sun's fiery heart, slowly fighting its way outward. The universe has no center. It's natural to imagine the universe expanding from a single point, like a balloon inflating. But if that's true, where's the center? The answer is everywhere and nowhere. Because space itself is expanding, every point can be considered the center. If you were in a distant galaxy billions of light years away, you'd see galaxies receding from you in all directions, just as we do from Earth. There's no special location, no cosmic landmark that marks the origin. The Big Bang didn't happen at a point in space. It happened everywhere at once. The universe is centerless, a vast expanding fabric with no edge and no middle, just endless stretches of space growing between the stars. Rogue planets drift alone through the galaxy. Not all planets orbit stars. Some have been ejected from their solar systems, flung into the void by gravitational interactions. These rogue planets wander through interstellar space, dark, cold, and alone. Without a sun, they receive no warmth, no light. Their surfaces, if solid, are frozen wastelands. Their skies are filled only with distant stars. Astronomers estimate there may be billions of these orphan worlds in the Milky Way, perhaps even more than there are stars. Some may have moons. Some may retain internal heat from their formation, enough to sustain subsurface oceans. They're invisible nomads, drifting through the dark remnants of systems that once were. Every atom in your body was once inside a star. The hydrogen in your body was created in the Big Bang. But the carbon, oxygen, nitrogen, and heavier elements were forged in the cores of stars. Over billions of years, stars fused lighter elements into heavier ones, building up the periodic table. When those stars died, they scattered their enriched material into space through supernova explosions or stellar winds. That material mixed into clouds of gas and dust, which eventually collapsed to form new stars, planets, and life. You are made of stardust, not poetically, but literally. Every atom in your bones, blood, and breath was once part of a star that lived, burned, and died long before the Earth existed. Space smells like burnt metal and seared steak. Astronauts who've conducted spacewalks report a distinct smell when they return to the airlock and remove their helmets. They describe it as metallic, like welding fumes, or slightly sweet, like seared meat. The smell doesn't come from space itself, which is a vacuum, but from particles that cling to their suits. These could be remnants of dying stars, oxidized metals, or complex hydrocarbons. When exposed to oxygen inside the spacecraft, these particles release their scent. It's a strange, lingering reminder that space, though silent and empty, is filled with invisible chemistry, the residue of cosmic processes clinging to fabric and metal. The fastest spinning object is a pulsar. Pulsars are already known for their rapid rotation, but one in particular holds the record. PSR J1748 2446AD, located in the globular cluster Terzan 5, spins 716 times per second, That means its surface is moving at roughly 24% the speed of light. At that speed, the star is stretched by centrifugal force, bulging at the equator. It's hard to comprehend that something the size of a city, with the mass of the Sun, can rotate that fast. But pulsars are held together by gravity so intense that even these extreme spins don't tear them apart. It's a cosmic whirlwind spinning faster than any human-made object, a blur of light and gravity in the dark. Some planets rain diamonds on gas giants like Neptune and Uranus. Conditions deep in the atmosphere may be just right for a very unusual kind of weather. High pressure and temperature can break down methane in the atmosphere, freeing carbon atoms. These atoms, under immense pressure, crystallize into diamond. Scientists believe that deep within these planets, it may literally rain diamonds, which sink toward the core. Similar conditions might exist on exoplanets around other stars. These diamond rains would be invisible, occurring far below the cloud tops, in layers no spacecraft has ever reached. But the chemistry is sound. In the crushing depths of distant worlds, jewels fall like rain. Voyager 1 is still sending signals from interstellar space. Launched in 1977, Voyager 1 has traveled farther from Earth than any other human-made object. In 2012, it crossed the heliopause, the boundary where the Sun's influence fades and interstellar space begins. It's now over 14 billion miles away, and its signal takes more than 22 hours to reach Earth. Despite its age and distance, Voyager 1 still sends back data about the environment beyond our solar system. Its power is fading, generated by decaying plutonium, and it will eventually go silent. But for now, it continues. A lonely emissary carrying a golden record with sounds and images of Earth. Drifting slowly through the space between the stars. The oldest known star is nearly as old as the universe itself. In the halo of the Milky Way, there's a star called Methuselah, or HD 283. It's estimated to be about 14.5 billion years old, with some uncertainty. That's nearly as old as the universe itself, which is 13.8 billion years old. This creates a bit of a puzzle, though refinements in the measurement have brought the numbers into better agreement. Methuselah is a low-mass star, which is why it has survived so long. It formed in the very early universe, when there were almost no heavy elements, just hydrogen and helium. It's a relic, a witness to cosmic history, still glowing faintly in the sky, older than almost everything around it. Mars has the largest volcano in the solar system. Olympus Mons, located on Mars, is the largest volcano we know of in the solar system. It stands about 22 kilometers high, nearly 3 times the height of Mount Everest, and its base is roughly the size of the state of Arizona. It's a shield volcano, formed by slow, steady lava flows over millions of years. Because Mars has lower gravity and no tectonic plate movement, volcanoes can grow much larger than on Earth. Olympus Mons is likely extinct now, but it's a monument to the planet's volcanic past. From its summit, the horizon would curve away in all directions, and the view would stretch across a rust-colored desert beneath a thin, cold sky. Some stars are cooler than a campfire. We usually think of stars as blazing hot, and most are. But a class of stars called brown dwarfs are so cool that some have surface temperatures lower than that of a campfire. Brown dwarfs are sometimes called failed stars because they never accumulated enough mass to sustain hydrogen fusion in their cores. They glow dimly with leftover heat from their formation, slowly cooling over billions of years. Some of the coolest brown dwarfs have temperatures around 100 degrees Celsius, or even lower. They're difficult to detect because they emit very little light, mostly in the infrared. But they're out there, dim embers drifting through the galaxy, too small to be stars, too large to be planets. A day on Venus is longer than its year. Venus rotates incredibly slowly on its axis, taking about 243 Earth days to complete one rotation. But it orbits the Sun in just 225 Earth days. That means a day on Venus, from sunrise to sunrise, is longer than a Venusian year. To make things stranger, Venus rotates in the opposite direction from most planets, a retrograde spin. If you could stand on its surface, the Sun would rise in the west and set in the east, though you'd never see it through the thick clouds. Time on Venus moves in strange rhythms, stretched and reversed, a reminder that even the basics like day and year depend entirely on where you are. Saturn's rings are disappearing. Saturn's iconic rings won't last forever. They're made of ice particles, ranging in size from grains of sand to house-sized chunks, all orbiting the planet. But these particles are gradually falling into Saturn, pulled by gravity and influenced by the planet's magnetic field. This process is called ring rain, and it's happening faster than scientists once thought. At the current rate, the rings could disappear in as little as 100 million years. That sounds like a long time, but in cosmic terms, it's brief. Saturn may not have had its rings for most of its history, and one day, perhaps soon, on a geological timescale, they'll be gone, leaving the planet bare and smooth. White dwarfs will be the last lights in the universe. In the far future, after stars have stopped forming and the universe has cooled, white dwarfs will be among the last objects still glowing. These stellar remnants, the leftover cores of stars like the Sun, don't generate new energy. They simply radiate the heat they've retained. This cooling process is incredibly slow, taking trillions of years. Long after red dwarfs have burned out and black holes have evaporated, white dwarfs will still be warm enough to emit faint light. Eventually, even they will fade, becoming black dwarfs, cold and dark. But for now, and for eons to come, they'll stand as quiet witnesses, the last embers in an aging cosmos. The age of the universe has been calculated using multiple methods: measurements of the cosmic microwave background, the expansion rate, and the ages of the oldest stars. All of these converge on a figure of about 13.8 billion years. That's how long it's been since the Big Bang, since time, space, and matter began. It's an almost incomprehensible span, long enough for stars to be born, live, and die many times over. Long enough for galaxies to form, collide, and reshape. And long enough for life to emerge on at least one small planet, orbiting an ordinary star, in a quiet corner of one galaxy among trillions. The universe is old, but it's still young compared to what may lie ahead. And so the journey continues, drifting softly through the cosmos, one fact at a time. Let your thoughts slow. Let the vastness settle around you like a blanket. There's more to explore, more wonders waiting in the dark. But for now, just rest. The universe is patient, and so are we. Supernovas can outshine entire galaxies when a massive star reaches the end of its life. It doesn't fade quietly. It explodes in a supernova, releasing more energy in a few weeks than our sun will produce in its entire lifetime. For a brief period, a single dying star can shine as brightly as all the billions of stars in its galaxy combined. These explosions are so luminous they can be seen from billions of light years away, appearing suddenly in the sky where no star was visible before. Ancient astronomers called them new stars, though they were actually the opposite, death rather than birth. The light carries with it the scattered elements forged in the star's core, seeding space with the raw materials for future worlds. Supernovas are both endings and beginnings, written in light across the cosmos. There are stars made almost entirely of diamond. When certain types of stars die, they leave behind white dwarfs, dense cores, roughly the size of Earth, but with the mass of the Sun. As these white dwarfs cool over billions of years, their carbon and oxygen can crystallize under immense pressure. The result is essentially a giant diamond, a star-sized gemstone floating in space. One such star, BPM 37093, has been nicknamed Lucy, after the Beatles' song Lucy in the Sky with Diamonds. It's located about 50 light years away and may have a crystalline core spanning thousands of kilometers. These diamond stars don't sparkle, they're far too hot. But deep inside, beneath layers of cooling plasma, lies a treasure beyond measure, forged not by geology, but by stellar death. You can see the Andromeda Galaxy with your naked eye. On a clear, dark night, far from city lights, you can see a faint smudge in the sky, near the constellation Andromeda. It doesn't look like much, just a dim, hazy patch. But that smudge is an entire galaxy, the Andromeda Galaxy, containing 1 trillion stars. It's 2.5 million light years away, meaning the light you're seeing left Andromeda long before humans existed. You're looking across unimaginable distance, witnessing an entire galaxy with nothing but your eyes. It's the most distant object visible without a telescope, a reminder that even in our smallness, we can reach across the void with nothing more than sight and wonder. The great red spot on Jupiter is shrinking. For centuries, Jupiter's great red spot has been one of the solar system's most iconic features. A massive storm larger than Earth, swirling in the planet's southern hemisphere. But observations over the past century show that it's getting smaller. In the 1800s, it spanned about 40,000 kilometers across. Today, it's less than half that size. Scientists aren't entirely sure why it's shrinking, whether it's a natural cycle or a sign that the storm is dying. If it continues at the current rate, the Great Red Spot may disappear within a few decades. For now, it still churns, a relic of atmospheric fury slowly fading into memory. Black holes can merge and create ripples in space-time when two black holes spiral toward each other. They don't collide like solid objects. Instead, they merge, their event horizons blending into one. In the final moments, they orbit each other at nearly the speed of light, releasing enormous amounts of energy not as light, but as gravitational waves. These ripples in space-time spread outward, stretching and squeezing space itself as they pass. In 2015, scientists detected these waves for the first time using LIGO, confirming a prediction Einstein made a century earlier. The collision lasted less than a second, but it sent a signal across the universe, a deep, silent rumble felt not by ears, but by detectors tuned to the fabric of reality itself. Mars once had rivers and lakes billions of years ago. Mars was a very different world. Evidence from rovers and orbiters shows that liquid water once flowed across its surface. Ancient riverbeds, deltas, and lake beds are carved into the Martian landscape, now dry and dusty. The planet likely had a thicker atmosphere and a warmer climate, conditions that might have supported life. But over time, Mars lost much of its atmosphere, possibly stripped away by the solar wind. The water evaporated or froze, and the planet became the cold, arid desert we see today. Still, beneath the surface, ice remains, and in shadowed craters, frozen water waits. Mars remembers a wetter past, even if its rivers have long since run dry. There's a planet where it rains glass sideways. HD 189733b is an exoplanet located about 64 light-years from Earth, and it's one of the most hostile worlds ever discovered. It's a gas giant slightly larger than Jupiter, orbiting so close to its star that surface temperatures reach over 1,000 °C. Its atmosphere is filled with silicate particles, which condense into tiny glass droplets. Winds on the planet reach speeds of 8,700 kilometers per hour, 7 times the speed of sound, blowing these glass fragments horizontally across the sky. The planet also appears deep blue, not from water, but from the way its atmosphere scatters light. It's beautiful and deadly, a world of scorching heat, shredded clouds, and storms made of glass. We've only explored about 5% of the ocean, but we've mapped most of the moon. Humans have walked on the moon, sent rovers to Mars, and launched probes beyond the solar system. But here on Earth, the deep ocean remains largely unexplored. We've mapped more of the moon's surface than the ocean floor. The depths are difficult to reach, dark, cold, and under crushing pressure. Yet we know there's life down there, strange creatures that thrive in conditions we once thought impossible. Similarly, space is vast and mostly unknown, but unlike the ocean, we can see across it. Light travels freely through the vacuum, revealing galaxies billions of light years away. The ocean hides its secrets behind water. Space, for all its emptiness, lays itself bare to those who look up. Some galaxies are cannibals. Large galaxies grow by consuming smaller ones, a process called galactic cannibalism. When a small galaxy wanders too close to a larger one, gravity takes hold. Over millions of years, the smaller galaxy is stretched, torn apart, and absorbed. Its stars are scattered into the larger galaxy's halo, forming streams and shells of light. The Milky Way is currently in the process of consuming several dwarf galaxies, including the Sagittarius dwarf elliptical galaxy. Evidence of past meals can be seen in the stellar streams that arc through our galaxy's halo. Remnants of galaxies that no longer exist as distinct entities. It's a slow, quiet consumption, one star at a time, until nothing of the original remains. The Sun will eventually become a red giant in about 5 billion years. The Sun will run out of hydrogen fuel in its core. When that happens, it will begin fusing helium, and its outer layers will expand dramatically. The Sun will swell into a red giant, growing so large that it may engulf Mercury, Venus, and possibly even Earth. Its surface will cool and redden, but its sheer size will make it far more luminous than it is today. Life on Earth, if any remains, will have long since ended, scorched by the Sun's increasing heat in the billions of years leading up to this transformation. Eventually, the Sun will shed its outer layers, leaving behind a white dwarf, a small, dense core that will slowly cool over trillions of years. Jupiter protects Earth from asteroids. Jupiter, the largest planet in our solar system, acts like a cosmic shield. Its immense gravity influences the orbits of asteroids and comets, sometimes deflecting them away from the inner solar system. While it can also fling objects inward, on balance, Jupiter has likely prevented countless impacts on Earth over the planet's history. Without Jupiter, Earth might have been struck far more often by large asteroids, making the emergence and survival of life more difficult. In this sense, we owe some gratitude to the giant planet, quietly pulling on rocks and ice far across the solar system, shaping the paths of wanderers, keeping some of them at bay. There are planets orbiting dead stars. Even after a star dies, planets can remain. When a star like the Sun becomes a white dwarf, its planets, if they survive the red giant phase, continue to orbit the cooling remnant. Astronomers have detected planets around white dwarfs, along with debris disks made of shattered asteroids and moons. In some cases, these planets may have migrated inward after the star's death, moving into orbits that were once too hot to occupy. These worlds orbit in silence, lit only by the faint glow of a dying ember. No warmth, no seasons, just the slow, cold fade of a star that once burned bright. The cosmic microwave background is the afterglow of the Big Bang. About 380,000 years after the Big Bang, the universe cooled enough for atoms to form. Before that, it was too hot, a glowing plasma where light couldn't travel far without scattering. But when atoms formed, light was suddenly free to move. That ancient light has been traveling through space ever since, stretched by the expansion of the universe into microwaves. Today, we detect it as the cosmic microwave background, a faint glow coming from every direction. It's the oldest light we can see, a snapshot of the universe in its infancy. By studying its tiny temperature variations, scientists can learn about the structure, composition, and history of the cosmos. Some stars pulse like heartbeats. Certain stars, called variable stars, change in brightness over time, pulsing in regular rhythms. Cepheid variables, for example, swell and shrink as they oscillate, their outer layers expanding and contracting. The period of these pulsations is directly related to the star's true brightness, making them invaluable for measuring cosmic distances. Other stars, like RR Lyrae variables, pulse even faster. These stellar heartbeats are driven by changes in the star's internal structure, layers heating and cooling in cycles. Watching a variable star is like listening to the cosmos keeping time. Each pulse a note in a long, slow melody played out over years or centuries. The longest sunset in the solar system lasts for months. On Mercury, the closest planet to the Sun, a day lasts 176 Earth days. Because of its slow rotation and elliptical orbit, sunsets and sunrises can be incredibly long and strange. In some locations, the sun appears to set, then rise again, then set once more, all in a single day-night cycle. This is due to Mercury's unique orbital resonance, where it rotates 3 times for every 2 orbits around the Sun. If you stood on Mercury's surface, you might watch the Sun hover near the horizon for weeks, slowly dipping and climbing in an eerie, drawn-out dance before finally sinking below the edge of the world. Ganymede is the largest moon in the solar system. Ganymede, one of Jupiter's moons, is not only the largest moon in our solar system, it's larger than the planet Mercury. It has a diameter of about 5,268 kilometers and is the only moon known to have its own magnetic field. Beneath its icy surface, scientists believe there's a subsurface ocean, possibly containing more water than all of Earth's oceans combined. Ganymede's surface is a mix of old, dark, cratered terrain and younger, lighter regions marked by grooves and ridges. It's a world of ice and mystery, a moon that might harbor the conditions for life hidden beneath a frozen shell, orbiting quietly in the shadow of a giant planet. Neutron stars have mountains, but they're tiny. Despite being incredibly dense and smooth, neutron stars can have surface features, tiny mountains or bumps just a few millimeters tall. That might not sound like much, but on an object where gravity is billions of times stronger than Earth's, even a millimeter-high bump represents an enormous amount of stress on the star's crust. These imperfections can cause the star to wobble slightly as it spins, and that wobble can release energy in the form of gravitational waves. Scientists have been searching for these signals, hoping to learn more about the structure and behavior of neutron stars, objects so extreme that even the smallest irregularity is a cosmic event. Pluto has a heart-shaped glacier. When NASA's New Horizons spacecraft flew by Pluto in 2015, it revealed a world far more dynamic and beautiful than expected. One of the most striking features is a large, bright, heart-shaped region called Tombor Regio. The western lobe, Sputnik Planitia, is a vast plain of nitrogen ice, smooth and bright, likely renewed by geological processes. Pluto, once thought to be a frozen, lifeless rock, turned out to have mountains made of water ice, a hazy atmosphere, and possibly even a subsurface ocean. Its heart, visible across millions of miles, became a symbol of the mission and a reminder that even the most distant, coldest worlds can surprise us with their complexity and charm. The universe could be infinite. We can only observe a finite portion of the universe, the observable universe, limited by the speed of light and the age of the cosmos. But beyond that horizon, the universe may continue forever. If space is flat, as current measurements suggest, it could extend infinitely in all directions. That would mean an infinite number of galaxies, stars, and planets, more than we could ever count or see. In an infinite universe, every possible arrangement of matter might occur somewhere, repeated across unimaginable distances. It's a dizzying thought, one that challenges our sense of uniqueness, but it's also strangely comforting. The idea that the universe has no edge, no boundary, just endless expanses of space and time. Some asteroids have moons. Asteroids aren't just solitary rocks drifting through space. Some have their own moons, small companions that orbit them. These binary or even triple asteroid systems form when collisions break off pieces, or when gravitational interactions capture passing objects. Ida, an asteroid in the main belt, was the first discovered to have a moon, a tiny satellite named Dactyl. Since then, hundreds of asteroids with moons have been identified. These systems offer insights into the history and dynamics of the solar system, showing that even among the smallest bodies, gravity weaves connections, pairing objects in slow, ancient dances. Space is completely silent. In space, no one can hear you scream, as the saying goes. That's because sound requires a medium to travel through, air, water, or another substance. In the vacuum of space, there's nothing to carry sound waves. Explosions, collisions, even the roar of a rocket engine would be completely silent if you were floating nearby. Astronauts communicate via radio because electromagnetic waves don't need a medium. The silence of space is profound, absolute. It's a quiet that swallows everything, a stillness broken only by the light of distant stars. In this vast, soundless cathedral, the universe moves without a whisper. Red dwarfs will outlive every other star. Red dwarfs are small, cool stars, the most common type in the galaxy. They burn their fuel so slowly that they can live for trillions of years, far longer than the current age of the universe. Some red dwarfs formed billions of years ago are still in their infancy, with most of their lives ahead of them. When larger stars have long since burned out and the universe has grown cold and dark, red dwarfs will still be shining, faint but steady. They'll be the last natural lights in the cosmos, glowing softly in the deep future, outliving galaxies, black holes, and perhaps even time itself, at least as we understand it. There's a diamond planet orbiting a pulsar PSR. J1719 1438 is a pulsar about 4,000 light-years away, and it has a companion unlike any other. Orbiting the pulsar is a planet with a density so high that it's likely composed largely of crystalline carbon, essentially a diamond. This planet is thought to be the remnant of a white dwarf star that was stripped of its outer layers by the pulsar's intense gravity and radiation. What remains is a superdense core, orbiting its companion every 2 hours. It's not a sparkling gem, but a dark, compressed world, locked in a tight orbit around a rapidly spinning dead star, a silent monument to stellar evolution's extremes. Galaxies rotate, but not like solid objects. When galaxies spin, they don't rotate like a wheel or a record. Different parts move at different speeds. Near the center, stars orbit quickly. Farther out, they move more slowly, but not as slowly as they should based on the visible matter alone. This discrepancy is one of the key pieces of evidence for dark matter. Without it, galaxies would fly apart, their outer stars moving too fast to stay bound. Dark matter provides the extra gravity needed to hold them together. So galaxies rotate in a way that reveals the presence of something we cannot see, an invisible mass that shapes their motion and structure. The coldest natural place in the universe is the Boomerang Nebula, about 5,000 light-years from Earth. There's a cloud of gas and dust called the Boomerang Nebula, and it's the coldest known natural place in the universe. Its temperature is about 1 Kelvin, just 1 degree above absolute zero. This extreme cold is caused by the rapid expansion of gas from a dying star at its center. As the gas expands, it cools, much like how a compressed air canister gets cold when released. The nebula is even colder than the cosmic microwave background, the faint afterglow of the Big Bang. In this tiny corner of space, something has achieved a stillness colder than the void itself. There are more trees on Earth than stars in the Milky Way. It's easy to assume the stars outnumber everything else, but Earth alone contains an estimated 3 trillion trees. The Milky Way, by comparison, has about 100 to 400 billion stars. That means our planet holds roughly 10 times more trees than there are stars in the entire galaxy. It's a humbling reminder of the richness of life, even on a single world. Each tree is a small living thing, but together they form forests that shape the atmosphere, anchor ecosystems, and breathe with the rhythm of the planet. We live on a world more abundant in trees than the galaxy is in suns. Time dilation means astronauts age slightly slower. Thanks to Einstein's theory of relativity, time moves differently depending on your speed and gravitational environment. Astronauts aboard the International Space Station orbit Earth at about 28,000 kilometers per hour, and they experience time dilation. They age very slightly slower than people on the ground, just a fraction of a second over the course of months. It's not much, but it's measurable. The faster you move, the more pronounced the effect becomes. If you could travel near the speed of light, you'd age far more slowly than those left behind. Time, it turns out, is not a fixed river, but a flexible current, bending with motion and gravity. Exoplanets come in types we've never seen before. The discovery of planets beyond our solar system has revealed an astonishing variety of worlds. There are hot Jupiters, gas giants orbiting closer to their stars than Mercury is to the Sun. There are super-Earths, rocky planets larger than Earth but smaller than Neptune. There are lava worlds, ocean worlds, and planets with clouds made of molten rock or metal. Some orbit two stars, like the sunsets in Star Wars. Others drift alone through the galaxy. The universe's imagination far exceeds our own, filling the cosmos with planets strange, diverse, and endlessly surprising. Every black hole has an event horizon. The event horizon is the boundary around a black hole beyond which nothing, not even light, can escape. It's not a physical surface, but a point of no return. Once you cross it, all paths lead inward. Time and space switch roles, and falling toward the singularity becomes as inevitable as moving forward in time. From the outside, the event horizon appears as a dark sphere, a silhouette against the universe. Anything that crosses it is lost to us forever, hidden behind a veil that no information can penetrate. The event horizon is the edge of the unknowable, a boundary written by gravity into the fabric of reality. Saturn could float in water. Theoretically, Saturn is the least dense planet in the solar system. Its average density is less than that of water, meaning if you could find a bathtub large enough, Saturn would float. Of course, this is purely theoretical. There's no body of water that size, and the planet would likely break apart under its own gravity if you tried. But it's a charming thought, a reminder that despite its size and beauty, Saturn is mostly gas and liquid, light enough to ride the surface of an imaginary ocean, its rings trailing behind like delicate foam. Space telescopes can see galaxies forming just after the Big Bang. With instruments like the James Webb Space Telescope, we can peer back in time to see galaxies that formed just a few 100 million years after the Big Bang. Because light takes time to travel, looking at distant objects is like looking into the past. These early galaxies are small, dim, and irregular, very different from the grand spirals and ellipticals we see nearby. Studying them helps us understand how the first stars formed, how galaxies grew, and how the universe evolved from a hot, dense state into the vast, structured cosmos we inhabit today. Every deep image is a window into history, frozen in light. Nebulas are stellar nurseries. Nebulas are clouds of gas and dust where stars are born. These regions can be vast, stretching across hundreds of light years, glowing with the light of young stars or the remnants of old ones. Some nebulas are bright and colorful, lit by the radiation of newborn stars within them. Others are dark, visible only because they block the light from stars behind them. Inside these clouds, pockets of gas collapse under gravity, heating up until nuclear fusion ignites. Stars emerge from the fog, bright and new, lighting up the nebula from within. These are the nurseries of the cosmos, where darkness gives way to light, over and over again. There's a giant wall of galaxies stretching across the universe. The largest known structure in the universe is the Hercules corona, Borealis Great Wall, a massive filament of galaxies stretching over 10 billion light-years across. It's so large that light takes billions of years to travel from one end to the other. This structure challenges our understanding of cosmic uniformity. As theory suggests, there should be a limit to how large structures can grow. Yet there it is, a vast wall of matter, shaped by gravity and dark matter over billions of years. It's a reminder that the universe organizes itself on scales almost beyond comprehension, weaving galaxies into patterns we're only beginning to map. Some comets take millions of years to orbit the Sun. Most comets we see, like Halley's Comet, have relatively short orbits, returning every few decades or centuries. But some comets come from the Oort cloud, a distant shell of icy bodies surrounding the solar system. These comets can have orbital periods of millions of years. They spend most of their time in the cold, outer reaches, far from the sun's warmth. Only occasionally, nudged by gravitational interactions, do they fall inward, brightening as they approach the sun, and then disappearing again into the dark for eons. A single orbit can span the rise and fall of entire species on Earth, a journey measured not in years, but in ages. The Earth's core is as hot as the surface of the sun, deep beneath your feet. At the center of the Earth lies a solid iron core surrounded by a liquid outer core. The temperature there reaches about 5,200 degrees Celsius, roughly the same as the surface of the sun. This immense heat is left over from the planet's formation and is sustained by the decay of radioactive elements. The core generates Earth's magnetic field, which protects us from harmful solar radiation. It's strange to think that the ground we walk on is just a thin crust floating above an inferno, a molten sea of metal spinning silently in the dark, holding the planet together and shielding life from the void. We are made of quantum particles. At the smallest scales, the particles that make up your body don't behave the way ordinary objects do. Electrons, protons, and neutrons follow the strange rules of quantum mechanics, existing in states of probability until observed. Particles can be in multiple places at once, tunnel through barriers, and become entangled across distances. The solidity you feel, the chair beneath you, the ground under your feet, is mostly empty space, held together by forces between particles that flicker in and out of existence. Reality, at its foundation, is far stranger than it appears. You are made of uncertainty, probability, and invisible fields woven into the shape of a person. Black holes can evaporate over time. According to Stephen Hawking, black holes aren't entirely black. They emit a faint radiation, now called Hawking radiation, due to quantum effects near the event horizon. This process is incredibly slow, but over unimaginably long timescales, a black hole can lose mass and eventually evaporate completely. For a black hole the size of the Sun, this would take far longer than the current age of the universe. But in the deep future, after stars have died and galaxies have faded, black holes will slowly shrink, releasing their energy bit by bit until they vanish in a final faint flash. Even the most permanent seeming objects in the cosmos are, in the end, temporary. The sun has been shining for 4.6 billion years. The sun formed from a collapsing cloud of gas and dust about 4.6 billion years ago, and it has been burning ever since. It's currently in the middle of its life, steadily fusing hydrogen into helium in its core. It's already outlived countless other stars and will continue shining for another 5 billion years. During that time, it will slowly grow brighter and hotter, eventually making Earth uninhabitable long before it becomes a red giant. The sun is both ancient and enduring, a constant presence in the sky, the center around which our world turns. It has witnessed the entire history of our planet, and it will outlast every living thing on it. The universe is still creating new stars. Star formation hasn't stopped. Right now, across the universe, new stars are being born in nebulas, collapsing clouds, and galactic collisions. The rate of star formation has declined since the universe's early years, but it continues. In the Milky Way alone, several new stars form each year. In more active galaxies, the rate can be much higher. These newborn stars will light up their surroundings, fuse elements, and eventually die, contributing their material back to the cosmos. The cycle continues, slower now, but still turning. The universe is not finished creating. It still makes light, still births suns, still writes new stories in fire and gas. Some moons have atmospheres. Not all moons are barren, airless rocks. Titan, Saturn's largest moon, has a thick atmosphere, denser than Earth's, composed mostly of nitrogen with traces of methane. Its surface is hidden beneath orange clouds, and it has lakes and rivers, not of water, but of liquid methane and ethane. Io, one of Jupiter's moons, has a thin atmosphere created by volcanic gases. Triton, Neptune's largest moon, has a tenuous atmosphere of nitrogen. These moons are worlds in their own right, with weather, geology, and chemistry unfolding in the shadow of their giant planets. They remind us that the solar system is full of complexity, even in the smallest corners. Light can be bent by gravity. Einstein's theory of general relativity predicts that massive objects warp space-time, and light, traveling through that warped space, bends along with it. This effect, called gravitational lensing, has been observed many times. Light from a distant galaxy can be bent around a closer galaxy or galaxy cluster, creating multiple images, arcs, or even complete rings called Einstein rings. Lensing allows astronomers to study objects that would otherwise be too faint to see, and it helps map the distribution of dark matter. It's a beautiful confirmation that space itself is flexible, and that light, though it travels in straight lines, follows the curves of the universe. The sun is traveling through space at 828,000 kilometers. The sun isn't sitting still. It's moving through the galaxy at about 828,000 kilometers per hour, or roughly 230 kilometers per second, carrying the entire solar system with it. We orbit the center of the Milky Way once every 230 million years, a period sometimes called a cosmic year. Since the sun formed, it has completed about 20 orbits. As we move, we pass through different regions of the galaxy, sometimes through spiral arms, sometimes through quieter spaces. The motion is smooth and constant, imperceptible from our perspective. But we are travelers, all of us, moving through the galaxy on a journey that began billions of years ago and will continue for billions more. The farthest human-made object is Voyager 1, launched in 1977. Voyager 1 has traveled farther from Earth than any other spacecraft. It's currently over 24 billion kilometers away, far beyond the influence of the sun, drifting through interstellar space. Its mission was to study the outer planets, but it kept going, becoming humanity's most distant messenger. It carries a golden record, a disk containing sounds and images of Earth, a message to any intelligent life that might one day find it. Voyager 1 will continue its journey for tens of thousands of years, eventually passing near other stars silent and alone, a small testament to human curiosity. The universe may end in a big freeze. There are several theories about how the universe might end. One of the most widely accepted is the big freeze, or heat death. In this scenario, the universe continues expanding forever, driven by dark energy. Over trillions of years, stars burn out, galaxies drift apart, and even black holes evaporate. Eventually, the universe becomes cold, dark, and nearly empty, filled only with faint particles and radiation. Energy spreads so thin that nothing can happen anymore. No stars form, no life exists. Just a vast, silent stillness stretching into eternity. It's not a violent end, but a slow, quiet fade, the universe gently exhaling its last breath. You are looking at the past when you look at the stars. Every time you gaze up at the night sky, you're seeing light that has traveled for years, decades, or even millennia to reach you. The light from the sun takes 8 minutes to arrive. The nearest star, Proxima Centauri, is 4.24 light years away, so you see it as it was over 4 years ago. Some stars you see are hundreds or thousands of light years distant, meaning their light began its journey long before you were born. You're not looking at the present, you're looking at a tapestry of the past. Each star a different moment in time, stitched together across the dome of the sky. The universe shows you its history, one photon at a time. There are storms on other planets that dwarf Earth's hurricanes. Jupiter's great red spot, though shrinking, is still a storm larger than Earth, and it has been raging for at least 400 years. On Neptune, winds reach speeds of 2,100 kilometers per hour, the fastest in the solar system. Saturn has a hexagonal storm at its north pole, a geometric shape that remains stable over decades. Exoplanets have their own extreme weather, some with winds that carry molten glass, others with temperatures that vary by thousands of degrees between day and night. Earth's hurricanes and tornadoes are fierce, but they're gentle compared to the vast, enduring tempests that rage on other worlds, storms that last for centuries and span continents. Thank you for journeying with me tonight. We've drifted together through the vastness of space, touching on stars, galaxies, black holes, and the quiet edges of existence. Some facts may have surprised you. Others may have simply washed over you like a gentle tide, soothing and soft. And perhaps, somewhere along the way, your thoughts began to slow, your breathing deepened, and the universe became a little less distant, a little more familiar. If you're still awake, know that the cosmos is always here, waiting to be explored. And if you've already drifted into sleep, may your dreams be as vast and beautiful as the universe itself. Rest well, and thank you for letting me guide you through the stars.